Hello my dear students, welcome to eCareerPoint-English Medium YouTube channel. So how are you all? Good? So we have started this chapter, motion in one dimension, and in previous classes we have discussed about speed, velocity and distance and displacement. And today's class we will start with acceleration. Okay? So before starting today's class, let me introduce you our toppers of this NEET examination. These 4 students, they have secured under 50 rank, all India rank in NEET. Okay, and they are our e-learning classroom students. So quickly download this eCareerPoint learning app because it is very much beneficial for NEET students, okay, as well as JEE. How to download it? Just go to Google Play Store, search eCareerPoint without any space, okay, and then you will see this app. Open this and install this app. After installing, you have to register, which is free of cost. After having registration, just follow your experts, okay, and you will be able to see the practice questions. Okay, and if you want my slides that I am teaching on this digital board, if you want all this presentation along my annotation, what you have to do, just go to this free stuff. Okay, go to this free stuff and then you will see this window. In this window you will find your 11th class physics English medium. Okay, all the free stuff, it is available in this section, free stuff. We have both paid and free courses over there, so it will be very much beneficial for you. Hello Shruti Singh. Okay, so let's get started with acceleration. What is acceleration? Okay, before starting the lecture, share this session to all of your friends so that they don't miss anything on this channel. Okay, let us discuss about acceleration. In previous classes, we have discussed about distance, displacement, speed, velocity. Today, we will start with acceleration. See, whenever acceleration is present, that means velocity will change. For example, see this. The car is having acceleration in forward direction, so its velocity is continuously increasing. Though the acceleration is constant, but because acceleration is present, its velocity is increasing. Okay? Now, velocity vector increases in the direction of acceleration. Okay, see, because it was initially at x, its acceleration direction is here, so velocity is increasing in this direction. Now after applying brakes, the acceleration becomes negative, that means it changes its direction, so the velocity decreases in that case. As you can see, this acceleration is constant and velocity is continuously increasing, and both of them initially they are having same direction. But when this applies brakes, the acceleration becomes negative, and then in that case velocity decreases. Whenever acceleration is in the direction of velocity, its speed increases. When acceleration is in opposite direction of velocity, the speed decreases. Okay, and what is the meaning of this? See, initially the acceleration is 1 meter per second. What does it mean? It means that its velocity will increase 1 meter per second in 1 second. This is what it means. So if acceleration is present in any motion, that means velocity will definitely change. Now, as you know, velocity is a vector quantity. So vector includes both magnitude and direction. Okay, it includes both magnitude and direction. If magnitude of a vector quantity changes, we say vector has been changed. If the direction of any vector quantity changes, we say the vector has changed. So vector changes whenever either its magnitude or direction or both changes. Okay, so if acceleration is there, that means definitely there will be some change in velocity. The change you may see in magnitude, or you may see in direction, or in both. Okay, so to understand this, let us solve this question. Which of the following is an accelerated motion? Option 1, motion in a straight line with varying speed. Okay, a particle is having straight line motion and its speed is changing. Is it an accelerated motion? Motion. Okay, actually the question is which of the following is not an accelerated motion? Okay, make this correction. Which not an accelerated motion? Motion in a straight line with varying speed, motion in a straight line with constant speed, motion in a circular track with constant speed, or motion in an circular track with varying speed. Okay, the question is asking which of the following motion is not an accelerated motion. Okay, this is the question. Now, we have studied that whenever acceleration is present, the velocity changes. If the velocity is changing, that means acceleration is present. So, if a body is not having any acceleration, that means its velocity should not change. Okay, the direction as well as magnitude of velocity should not change if the particle is not having any acceleration. Okay, see, motion in a straight line with varying speed. Varying speed means, I told you instantaneous speed is same as the magnitude of instantaneous velocity. So, if speed is changing, that means magnitude of velocity is changing. So, it is an accelerated motion. So, it is not the answer. Motion in a straight line with constant speed. Okay, motion in a straight line means a particle is moving on a straight track. Okay, and its magnitude of velocity is not changing. Because it is moving in a straight track, neither of its direction or magnitude is changing. So, option 2 is the correct answer. Motion in a straight line with constant speed is, we can say it is not an accelerated motion if it is not changing its direction. Option 3, motion in a circular track with a constant speed. Okay, if a particle is moving in a circular track, that means its velocity at every instant is changing its direction. Okay, so because direction of velocity is changing, that means this motion is an accelerated motion. So, it is not an answer. Last option, motion in a circular track with varying speed. That means now its velocity, magnitude and direction all are changing. So, definitely fourth one is not the answer. So, the only answer is option 2. Motion in a straight line with a constant speed without changing the direction is non-accelerated motion. Okay. Now, let us discuss mathematical form of acceleration. What is acceleration? How acceleration is defined? Okay. It is defined as rate of change of velocity with respect to time. If velocity is changing as the passage of time, that means acceleration is there. And its value is rate of change of velocity. That means if we talk about instantaneous value, it is differentiation of velocity with respect to time. Okay. Second point, it is a vector quantity. Acceleration has direction and magnitude both, so it is a vector quantity. Third point, which is very important, the direction of acceleration is same as the direction of change in velocity. There is a difference between velocity and change in velocity. If velocity is changing, okay, so final velocity minus initial velocity will be known as change in velocity in vector form. Final velocity minus initial velocity. This is known as change in velocity. Okay. So, what is the direction of acceleration? Direction of acceleration is same as the direction of change in velocity. It is not same as the final velocity, not same as the initial velocity. It is same as the change in velocity. Now, to understand this concept, let us have an example. See, a particle is moving eastwards with a velocity of 5 meters per second. Then the velocity changes to 5 meters per second northwards. Then calculate the direction of acceleration. Okay, direction of average acceleration it is asking. So what is the direction of acceleration? The direction of acceleration is same as the change in velocity. So how do we find change in velocity? Change means final value minus initial value in vector form. Okay, so we have to do the vector subtraction. Now see this, a particle is moving eastward with a velocity of 5 meters per second. Okay, so that means, let us assume this is east, this is west, this is north, and this is south. Okay, so initial velocity is in this direction, eastwards, v initial. And what is that? It is 5 meters per second. If I take this as positive x-axis and this as positive y-axis, then this I can write initial velocity vector is 5 I cap meter per second. Okay. Now, then its velocity changes to north direction, keeping the magnitude same, as you can see. So its final velocity will become 5 j cap. Okay. Now what we have to find? We have to find the direction of average acceleration. That is the change in velocity. Direction of average acceleration is same as the change in velocity. Okay. So what is change in velocity? How to find change in velocity? Change in velocity is equals to final velocity minus initial velocity. So what is final velocity? This is final velocity, Vf, which is equals to 5 j cap. And if I add final velocity with negative of initial velocity, I will get the change in velocity. So what is negative of initial velocity? Just change its direction, just make its direction opposite. This vector will be known as negative of initial velocity, which is equals to minus 5 I cap. Now, what is change in velocity? It is addition of final velocity with negative of initial velocity. Okay. Good, very good, Vinila Verma, well done, you are right. So see, if I add these two vectors, I will get this vector, that is change in velocity. Okay. So as you can see, the direction of change in velocity, which is the direction of acceleration also, is in the direction of northwest. So the correct answer is option 4. The direction of acceleration is northwest. Okay, so this is how we are going to find the direction of change in velocity. Is it clear to all of you? Okay. Now, we define average acceleration. What is average acceleration? Just like average velocity was total displacement upon total time. Total displacement means total change in position vector. Similarly, average acceleration is change in velocity upon time taken to change that velocity. That is the average acceleration. Okay, that means final velocity minus initial velocity in vector form, because acceleration is a vector quantity, divided by time taken to change the velocity. Whenever the question asks you to find out change in velocity, to find out average acceleration, he will give you, the question will give you the time period, that this is the time period, find out the average acceleration in this given time period, because in denominator we have that time period, that is the time taken to change this velocity. Okay. Now, what is instantaneous acceleration? Instantaneous acceleration is the rate of change of acceleration with respect to time. That means change in velocity in a very small duration of time. It is instantaneous acceleration. That means acceleration at a particular instant. Okay. So what is average acceleration? Change in velocity upon time taken to change that velocity. It can be calculated only when we have a time period. And what is instantaneous acceleration? It is the acceleration at a particular instant, which can also be treated as the change in velocity upon time when the time duration is very less. Okay. So that is why it is limit delta t tends to 0, delta v by delta t, which is dv by dt. dv by dt means differentiation of velocity with respect to time. Okay. Now, instantaneous acceleration, if particle is moving only in x direction and both velocity and acceleration are in x direction, it can be written like v into dv by dx. Why? Because if particle is moving only in x direction, that means its velocity will be dx by dt. And what is acceleration? Acceleration is dv by dt. If I multiply this by dx upon dx. Dx by dx means it is equals to 1. If I multiply any quantity with 1, it will not change. So now see this. This dx by dt will become v. So I can say acceleration is equals to this v times dv by dx. Okay. So the instantaneous acceleration, it can also be written like this. Either rate of change of velocity with respect to time, or instantaneous velocity multiplied by rate of change of velocity with respect to displacement. Okay. Again, let us have a question of average acceleration. See, it is the same question as previous, but now you have to find the magnitude of acceleration also along with the direction. Okay. A particle is moving eastward with a velocity of 5 meters per second. In 10 seconds, the velocity changes to 5 meters per second northwards. Okay, initially it was moving in eastwards, now it is moving in northward. So it is asking the average acceleration in this time is. What is the average acceleration? And if you see the options, it is asking the magnitude of average acceleration along with the direction. It is not asking the vector form, it is asking the magnitude and direction separately. So we have calculated the direction. Now let us calculate the magnitude. We should know how to calculate magnitude also. Okay. So see, again let us assume that this is east, this is west, this is north, this is south. Okay. Particle is moving in eastward direction. That means this is the v initial. That means it is 5 meters per second, or in vector form we should write it as 5 I cap if I am taking these as axes. So this is initial velocity which is in the east direction. After 10 seconds, its velocity becomes 5 meters per second in north direction. That means it becomes 5 j cap. Now, what is average acceleration? It is final velocity minus initial velocity vector divided by time taken. So as you can see, final velocity vector is 5 j cap minus initial velocity vector is 5 I cap divided by 10. So use this relation. That means average acceleration in vector form is equals to half j cap minus half I cap. So if we calculate the magnitude of average acceleration, it will be under root of half square plus minus half square. So average acceleration magnitude, okay, this is not vector sign here, so it is magnitude. It will be equals to under root 2 by 2, that is 1 by root 2. So 1 by root 2 is the magnitude of this acceleration, and direction we have already calculated in previous question, that is northwest. So answer is option 2. The average acceleration to change this velocity from this to this, taking time 10 seconds, is 1 by root 2 in the direction of northwest. This is the direction of average acceleration. Is it clear to all of you? Good. Vanilla, good. Very good. Okay. Very simple. Just follow the concepts and you will not get disturbed by the question. Okay. Next question. This question is based on instantaneous value of velocity and acceleration. See, the displacement of a particle moving in a straight line depends on time as, see, x coordinate is given. Particle is moving along x axis, okay, and its x coordinate at any time is given. X coordinate is dependent on time. If you put t equals to 1, you will get its x coordinate at t equals to 1 second. If you put t equals to 2, you will get its x coordinate at t equals to 2 seconds. That means its x coordinate is continuously changing. That means particle is having motion. Okay, so it is asking the ratio of its initial acceleration to its initial velocity. Okay, what we are going to do, see, if x coordinate is changing, that means change in x coordinate is the displacement. Change in x coordinate is the displacement. That means instantaneous velocity will be given by dx by dt. If you differentiate this term with respect to time, you will get instantaneous value of velocity. Then again, if you differentiate velocity with respect to time, you will get instantaneous value of acceleration. Okay, so let us solve this question. In previous class, I have told you the concepts of differentiation. Now, see this. What is velocity? Velocity is dx by dt. Alpha is a constant. Alpha, beta and gamma, they are constants. Okay. Differentiation of t cube will be 3t square. Differentiation of t square will be 2 into t to the power 1. Differentiation of t to the power 1 will be t to the power 0. That means 1. And differentiation of constant is 0. So, we have velocity as 3 alpha t square plus 2 beta t plus gamma. Okay, this is the value of instantaneous velocity, which we got by differentiating this. Differentiating displacement or position with respect to time, we will get instantaneous velocity. Okay, now if we again differentiate this function, we will get acceleration. What is acceleration? Acceleration is dv by dt. That means rate of change of velocity with respect to time, or we can say it is double differentiation of x with respect to time. Okay, so again differentiate this. The differentiation of t square will be 2t, so it will become 6 alpha t. Differentiation of 2 beta t, it will be 2 beta. Okay, so this is the value of acceleration. This is velocity at any particular instant. This is acceleration at any particular instant. Good, well done, Vanilla, very good. So, as you can see, the velocity is dependent on time. That means velocity is not constant. This is variable velocity. Velocity is variable, that means velocity is changing. It implies acceleration is not 0, acceleration is having some value. And if you see the acceleration, acceleration is also dependent on time. As time is increasing, acceleration is also increasing. That means acceleration is also time varying. Okay, it is also variable. Variable acceleration. Now, it is asking the ratio of initial acceleration to the initial velocity. Initial means at t equals to 0. Initial means just when we started observing. At t equals to 0 means initial value. Okay, so for initial velocity, that means velocity at t equals to 0, what we have to do? We have to put t equals to 0 in this function. So we will get velocity at t equals to 0, which is initial velocity. So initial velocity, put t equals to 0 here, you will get it is equals to gamma. And acceleration at t equals to 0, to find out, put t equals to 0 in the function of acceleration. This is acceleration as a function of time. Put t equals to 0, you will get acceleration at t equals to 0. That means initial acceleration. So as you can see, initial acceleration is 2 beta, initial velocity is gamma. So their ratio, that means acceleration at t equals to 0 and velocity at t equals to 0, it is 2 beta by gamma, which is only dependent on beta and gamma. So answer is option 3. It was asking the dependency of this ratio initially. Okay, initially. If I ask you the dependency of this ratio at any instant of time, then we will include alpha also. Is it clear to all of you? If you learn physics step by step, you will feel it is very easy. That is why I am taking so much examples. So share this session to all of your friends and do hit the like button and subscribe the channel if you are new, so that you can get the notifications on the time. Press the bell icon to get the notifications. Okay, let us talk about acceleration and deceleration. Okay, deceleration is also known as retardation. Okay, that's as you have studied in previous classes, 9th class, like you have studied about motion in only one dimension. Okay, in which acceleration is either parallel to velocity or anti-parallel to velocity. Okay, but in this class we will study some more different cases when acceleration and velocity, they are having some angle between them. So let us discuss about acceleration and retardation. See, what is the meaning of acceleration? Basically, in mathematical form, acceleration means rate of change of velocity with respect to time. But when we compare acceleration and retardation, in that case, acceleration means velocity is increasing, speed is increasing, and retardation means speed is decreasing. So whenever speed is increasing, that means you are having acceleration. Whenever speed is decreasing, that means you are having retardation. Generally, we discuss these two cases when either velocity is parallel to acceleration or anti-parallel to acceleration. Okay. For example, this. See this. Because acceleration is a vector quantity, it will have direction. See, the car is moving in positive x direction, and both velocity and acceleration, they are in same direction. Velocity increases in the direction of acceleration. So at the next moment, it will have some increased velocity in the same direction. That means magnitude of velocity increasing. So we can say speed is increasing. So this is the case of acceleration. The car, we will say it is accelerating. Okay. Now look at the second case. In this case, the velocity is in positive x direction, but acceleration is in negative x direction. It happens when, see, the total acceleration is in the direction of net force. If the net force on this is in backward direction, that means it is retarding. See, velocity is in this direction, acceleration is in opposite direction. Angle between acceleration and velocity is 180 degree. Okay, so you know the velocity increases in the direction of acceleration. That means at the next moment there will be increase in velocity in backward direction, due to which the net velocity magnitude will decrease. Because magnitude of velocity is decreasing, then we will say speed is decreasing. So this is the case of retardation. Okay. Vanilla, we can say if both of them are opposite to each other, that means this is the case of retardation. If they are in the same direction, they are parallel to each other, this is the case of acceleration. This statement is more correct. Okay. See the third case. Now, velocity is in negative x direction, but acceleration is in positive x direction. So what will happen? The velocity will increase in the direction of acceleration, so there will be an increment of velocity in this direction, due to which the magnitude of net velocity will decrease. That means speed is decreasing, so this is the case of retardation. It is retarding. Now, let us see the fourth case. Both acceleration and velocity, they are in negative direction. Velocity increases in the direction of acceleration, so just at the next moment, its velocity will be magnitude of velocity will be more than the previous. That means speed is increasing, so this is accelerating. Hence, we can conclude, if we compare two cases when acceleration and velocity, they are either parallel or anti-parallel. When they are parallel, the case will be accelerating. When they are anti-parallel, the case will be retardation. Okay. So this is the difference between acceleration and retardation or deceleration. Clear to all of you? Okay. Now, some basic terms that are very important. Uniform acceleration. Uniform means constant value. If in the entire journey, particle acceleration is having same direction and same magnitude, then we will say the acceleration is uniform. Okay. Next, non-uniform acceleration. Non-uniform acceleration means if acceleration is changing, that means instantaneous value of acceleration is changing. That means it is the case of non-uniform acceleration. Now, because acceleration is a vector quantity, so change in acceleration means either if velocity magnitude changes of acceleration, that means acceleration is changed. If direction of acceleration is changing, that means acceleration has been changed. So uniform acceleration means if direction as well as magnitude of acceleration is not changing, I am talking about instantaneous value, okay, if it is not changing in the entire journey, that means the journey was in uniform acceleration. If either magnitude or direction or both changes of acceleration, that means it is a case of non-uniform acceleration. Okay? Let me take an example to make it clear. If a car is moving, if the driver is accelerating the car, that means its acceleration is in this direction and velocity is in this direction. So until acceleration is there, having same magnitude and same direction, we will say it is uniform acceleration, because acceleration direction is not changing. If we throw a particle, what happens? Due to gravity, it experiences a downward acceleration all the time. So at every moment, the acceleration magnitude and direction is same. Near the surface of Earth, we can assume that the gravitational force is same. Okay? Now let us discuss about non-uniform acceleration. See, if a particle is moving in a uniform circular motion means it is moving in a circular track having constant speed. For uniform circular motion, the acceleration is always towards the center. If a particle is here, its velocity will be here, and this is the acceleration. If it comes here, its velocity is changing, as you can see, and acceleration direction is also changing. So this is the case of non-uniform acceleration, and these are the case of uniform acceleration. Is it clear to all of you? Okay. Now, let us have some questions for practice. The position x of a particle varies with time as this. This is the x coordinate of the particle which is changing. That means particle is having motion. Okay. The acceleration at time t of the particle will be equals to 0, where t is equals to. Okay. It is asking the time when acceleration is 0. So what you have to do? First, because you have position as a function of time, if you differentiate position, you will get velocity as a function of time. If you again differentiate velocity, you will get acceleration as a function of time. If acceleration as a function of time is constant, if it is not a function of time, it is constant, then we will say acceleration is uniform. If it is dependent on time, we will say it is non-uniform. Okay? So you have to calculate that time when acceleration is 0. So, yes, Vinila, first we have to find velocity as a function of time. Okay? As a function of time, not at a particular time. Okay? If we differentiate velocity as a function of time, then only we will get acceleration. If you differentiate velocity at a particular time, you will not get acceleration, because velocity at a particular time you will have a fixed value and you will treat it as constant. Okay? Good. Well done. Very good. You have given the correct answer. Well done, beta. Okay. So let us solve this question. We have position as a function of time, a t square minus b t cube. Okay, the question is using a. So we will not use a for acceleration. We will use some another letter. If we differentiate x with respect to time, we will get velocity. Differentiate x as a function of time, we will get velocity, because particle is only moving along x-axis. Okay, it is a straight line motion. So it is equals to 2at minus 3bt square. Let's say capital A is the acceleration, so it will be dv by dt, rate of change of velocity with respect to time. Again differentiate it, you will get 2a minus 6bt. So as you can see, this acceleration is non-uniform. Non-uniform means the acceleration is not constant, it is changing as the passage of time. So it is asking the time when acceleration is 0, time when acceleration is equals to 0. Okay, how to calculate? Put acceleration is equals to 0, which is 2a minus 6bt. Now you can find the time. Time is equals to 2a by 6b, which is equals to a by 3b. At this time, acceleration is 0. So answer is option 3. only at this time acceleration is 0. At any other time, it is having some value. Okay? Because the acceleration is non-uniform, so it is changing its value as the passage of time. Okay? This is the case of non-uniform acceleration. And this is straight line motion. The particle was having motion along the x-axis only. Okay? And its x coordinate, which is position, as a function of time, is given like this. So its velocity, you can find out. If velocity is positive at any moment, that means it is going to positive x direction. If velocity is negative at any moment, that means it is going to negative x direction, because physical meaning of differentiation is rate of change of value. Okay, if x is decreasing, that means velocity is negative. If x is increasing, that means dx by dt is positive, velocity is positive. Okay. Yes, Aryan. I take the NEET question also. Okay, as you can see, this was asked in AIPMT, old time. Okay, so you can ask your friends. Also, I suggest you to watch all these lectures, because I am going to cover entire syllabus of NEET along with practice. Okay, practice means Menti quiz. I will take some test, Menti quiz. Okay, for practice. Okay, so let us solve this question. Again, this was asked in the medical examination, although it is very old exam, but we can solve this. A particle moves along a straight line such that its displacement at any time is given by t cube minus 6t square plus 3t plus 4 meters. Okay, then find out the velocity when acceleration is 0. Read the question carefully. And then if you are new, I suggest you to hit the subscribe button so that you can get the notification of important lectures and some quiz. Okay, hit the like button, also the subscription, and hit the bell icon. Now try to answer this question. It is asking the velocity when acceleration is 0. That means by reading the question, we can assume that acceleration is non-uniform, which is changing as the passage of time. Also, velocity is not uniform because it is changing as the passage of time. So first, what we will do, we will differentiate it and we will find velocity. Again, we will differentiate it, then we will find acceleration. We will put the acceleration equals to 0 and we will see what is the time. And we will put that time in the formula of velocity as a function of time, and we will get velocity at that time when acceleration is 0. Well done, Vanilla, you have given the correct answer. Well done. Just ask your friends also to watch this session so that I can start taking quiz. Okay? I will take quiz. You know all about Menti quiz. I will display some question and you will submit those answers using another website. And I will display who has given the correct answer and who has given the wrong answer. Okay? So let us start solving this question. We have displacement as a function of time. That is, s is equals to t to the power 3 minus 6t square plus 3t plus 4. If you differentiate this, see, velocity is simply differentiation of displacement. If particle is moving only along x-axis, we write dx by dt, because that is only displacement is only change in x coordinate. Okay? If it is moving along only y-axis, then we will write it dy by dt. But we do not know in which direction it is moving, but this motion is a straight line motion. So it is ds by dt. Differentiate this and see what you are getting. You will get 3t square minus 12t plus 3. This is velocity as a function of time. If we put any time, we will get velocity at that time. Now, to calculate acceleration, differentiate velocity again, or I can say this is double derivation, double differentiation of displacement. So differentiate it, you will get 60 minus 12. This is the acceleration. Okay, so let us calculate time when acceleration is 0. What is the time when acceleration is 0? Put acceleration 0, it is equals to 6t minus 12. You will get t is equals to 12 by 6. That means at t equals to 2, acceleration is 0. At t equals to 2, acceleration is 0. So it is asking the velocity when acceleration is 0. Put the time t equals to 2 in this equation. Okay. So velocity when acceleration is 0. That means t equals to 2. Okay, as you can see, acceleration is a function of time. It is changing as the passage of time. Also, velocity is a function of time, which is changing as the passage of time. So both of them, they are non-uniform. Okay, so we have put this acceleration 0 and we have calculated the time when acceleration is 0. Now we will put this time in this equation and we will get the velocity at the time t equals to 2 when acceleration is 0. Okay, so put here, you will get velocity is equals to 3 into 2 square minus 12 into 2 plus 3, which is equals to this is 4 multiplied by 3, 12 minus 24 plus 3. So what is this? This is minus 12 plus 3, which is equals to minus 9 meter per second. Velocity is minus 9 meter per second. That means its direction is opposite. So answer is option 4. Okay. Good, Vanilla, very good. Well done. Very good. So, see, physics is very easy. But if you, physics is like going upstairs. If you skip any step, you will find it very difficult. So, if you study step by step, okay, starting from 0 level and going to hero level, then you will feel physics is very easy. So, I will take a lot of example, a lot of questions to make physics easy for you. So, quickly like this session and hit the subscribe button and also share this session to all of your friends. Now, next question, and this is for you. If the velocity of a particle moving in a straight line is 10 plus 2t square meter per second, then what is the average acceleration of the particle between 2 seconds and 5 seconds? Okay. If you know the difference between average acceleration and instantaneous acceleration, then you will be able to solve this question. Try to solve it. See, velocity as a function of time is given. Velocity is 10 plus 2t. This is instantaneous velocity. And what is instantaneous acceleration? Instantaneous acceleration is rate of change of velocity with respect to time. So if you differentiate it, what will you get? This is 2t square. If you differentiate it, what will you get? You will get 4t. But see, question is asking average acceleration, not instantaneous acceleration. So instantaneous acceleration value is useless for us. So this method is incorrect. It is asking the average acceleration. Good, Vanilla, very good. You have given the correct answer. Well done. So what is average acceleration? We should go to definition. Do not find average of different acceleration. Okay, if you are finding acceleration at t equals to 2, acceleration is t equals to 5 and you are finding its average, this is the wrong method. Okay, what is the definition of average acceleration? It is change in velocity upon time taken to change that velocity. Good, good. Yes, this is the correct formula. Well done. Okay, so correct answer is option 4. Let us see how it is correct. It is given in the question that the particle is having straight line motion. Okay, and its velocity, its displacement, its position is not given as a function of time. Its velocity as a function of time is given. At any time t, velocity is given. Okay, so at t equals to 2, suppose its velocity is initial velocity. At t equals to 5, suppose its velocity is final velocity, and because they are moving in same direction, same straight line motion, so there is no use to have vector addition or vector subtraction, because if the direction is same, we can do vector addition or subtraction in scalar form, algebraic form. So first of all, calculate velocity at t equals to 2 seconds. Then calculate velocity at t equals to 5 seconds. So what is initial velocity? Initial velocity at t equals to 2 seconds. At t equals to 2 seconds, if you want to find velocity, put t equals to 2 in this equation. Okay, so it will be 10 plus 2 into 2 square. So this is 4 into 2, 8. So initial velocity is 18 meter per second. Now at t equals to 5 seconds, this is final velocity, which is equals to, put t equals to 5 here and you will get 10 plus 2 times 5 square. This is 25 into 2, 50, 50 plus 10, 60 meter per second. So this is the initial and final velocities. Okay. So because the direction is same, both of them are positive, the direction is same, the diagram is correct that we have assumed. So we can say acceleration, average acceleration. Okay, it is asking average acceleration. This is instantaneous acceleration, it is not asking instantaneous acceleration. If question is asking only acceleration, that means it is asking instantaneous acceleration. If it is specifies average acceleration or it has given the time period, that means it is asking average acceleration. It is equals to final velocity in vector form minus initial velocity in vector form divided by time taken. Because both of them, they are having same direction, so vector form can be easily calculated by doing algebraic calculations. So final velocity minus initial velocity, that means 60 minus 18. And time taken to change this velocity is 3 seconds. As you can see, this is 3 seconds. Delta t is 3 seconds. 5 minus 2 is 3 seconds. Rather, for complete solution, we should write 5 minus 2. Okay. So what is average acceleration? This is 42 divided by 3. So average acceleration is 14 meter per second square. Okay. This is instantaneous acceleration. That means acceleration is changing continuously. But it is not asking instantaneous acceleration, it is asking the average acceleration. So this is the answer. Option 4 is the correct answer. Is it clear to all of you? Yes, Vanilla, your solution is also correct. Well done. Very good. Okay, so just go step by step and you will feel physics is easy. Many of you, you may think that physics is very easy, there is no need of practice. No. Initially it seems to be easy, but when it gets complicated, so you will be able to solve question only when your concepts are clear. And practice is very important to clear the concept. In physics, only theory is not sufficient. That is why I am taking so much illustrations so that it can be clear to you. The concept clears. You can clear the concept by practicing. Okay. And to practice the question, download eCareerPoint Learning app. You will be able to see the questions that you can attempt free of cost. Okay, it has paid and free courses both. Now, next question. The x and y coordinates of a particle at any time t are given by. X coordinate is a function of time, y coordinate is also a function of time. That means its x and y coordinate, they are changing. Both of them, they are changing. So it may or it may not be the question of motion in one dimension, but still we can solve from our concept. We can assume the change in y direction concept separately, change in x direction concept separately. So see this. This is x and y coordinate at any instant of time. This is suppose x axis, this is y axis. This is not a graph, this is the coordinate. Okay, this is not the graph that shows you the change in y with change in time. Okay, this is it is showing the position. This is x and y coordinate. X coordinate is changing as the passage of time, y coordinate is also changing. So what is it asking? It is asking the acceleration of the particle at t equals to 5 seconds. So listen carefully, the concept that we are using, velocity in x direction, that means x component of velocity, it is dx by dt, and y component of velocity it is dy by dt. Similarly, x component of acceleration is dvx by dt, and y component of acceleration is dvy by dt. By differentiating the x coordinate, you will get velocity in x direction, or we can say the component of velocity in x direction. Okay, differentiate x coordinate, you will get velocity in x direction. Differentiate y coordinate, you will get velocity in y direction. And if you want to find the net magnitude of velocity or the net velocity, do the vector sum. This is v net. Okay. You can also find the magnitude of v net, which is under root of vx square plus vy square. Under root of vx square plus vy square. Also, net acceleration is equals to under root of ax square plus ay square. That means x component of acceleration square plus y component of acceleration square whole under root. Yes, Vanilla, very good. You're right. Well done. So this is how we can calculate the components of velocity and acceleration. And if we know the components, you know about the vectors. If you know the components, you can calculate the vector. Okay. See, your chemistry teacher has also joined the class, Nikhil sir. Okay. So say hello, show your respect to Nikhil sir. And do hit the subscribe button. Okay. Thank you, Nikhil sir. Thank you so much. So here, let's start to solve the question. Now I have explained the concept to you. Now we can solve the question. See, this is displacement. This is the final position vector. I would say it is position vector. Okay, this is position vector. What is this? Position vector is equals to x coordinate I cap plus y coordinate j cap. And rate of change of position vector is equals to the velocity. Okay, so this is x coordinate I cap plus y coordinate j cap. So just differentiate it and you will get 7 plus 8t I cap plus differentiate it, you will get 5 j cap. So this is the x component of velocity, this is the y component of velocity. Okay, this is x component of velocity, this is y component of velocity. As you can see, x component of velocity is changing as the passage of time. So x component is variable in this case, but y component is constant. Now if you want to find acceleration, it is equals to rate of change of velocity vector with respect to time. Okay, what is velocity? It is rate of change of position vector, and rate of change of velocity vector is acceleration. So differentiate it again and you will get acceleration. As you can see, by differentiating you will get acceleration as 8 I cap. That means acceleration has only x component, it has no y component. Okay, it has only x component. So to calculate net acceleration, a net, it will be equals to under root of x component square plus y component square. Okay, so what is net acceleration? Y component is 0, square of 8 under root, it is equals to 8 meter per second square. Okay, so this is the net acceleration. Option 2 is the correct answer. Is it clear to all of you? Okay, so this is how you can solve the questions. We will learn step by step. I will take small every topic and a lot of question for that. Okay, so be regular in class and ask your friends also to join the session. Okay, after some session I will take quiz. Okay, it will be a digital quiz in which you will be able to submit your answers to me and I will show your result on this digital board. Okay, so I am giving you a question for homework. This is your homework question. You are going to solve it. Okay, its answer is option 2. This is again your homework question. Hint is given to you. Its answer is option B. This question was asked in a competitive exam. Okay, so before coming to next class, you are going to solve these questions. How will you solve this question? Okay, you should know how to get this PDF, how to get this presentation in PDF format. I am going to give you these slides, okay, by this app, eCareerPoint Learning app. So what you have to do to get my slides, to get my notes, okay, if you want to take the notes, what you have to do, download eCareerPoint app. How to download it? Open your Android device and go to Google Play Store. In Google Play Store, search eCareerPoint without any space and you will see this app. Open this and install this app. This is an amazing app and it is very beneficial for this situation of COVID. Okay, at your home you can learn many things from this app. If you install it, you will see a registration form. Just enter your registration details and it is free of cost. Once you install it, if you want to get my notes along with my video lectures, just follow me. Follow your experts and then you will be able to see the question posted by your experts. And you will attempt these questions free of cost. Okay. Now, to get these notes, go to this section free stuff. In this free stuff, you will see this window. Okay, this is the complete free stuff and in this window you will find the 11th physics class for English medium students. At that you will be able to see my previous lectures along with the notes in PDF format. Okay, good Vanilla, very good. Thank you so much. So to get these notes, because to solve these homework questions you should have this slides. Okay, and along with that, practice all the class illustration that I have solved. Okay, so let's end this session. Subscribe, hit the subscribe button if you are new so that you never miss any latest update. Share this session to all your friends and I will be start taking the Menti quiz. Okay, digital quiz system. Hit the like button and comment on this video if you like it. Okay. So this is Sumit Talwani signing out. Thank you very much.